All right. Welcome back. Day 2, week 1, May 12th. Today I wanted to go over this magical tool, Jupyter Notebook, and Anaconda Python. If you Google it, you will find Anaconda Individual Edition, Anaconda Python Individual Edition. They're up to 2021.11, and Python 3.9 is the actual version of Python. I need to do a little bit of Googling because um, once you download Anaconda, you can use that to refresh your environment, but I'm not real good at that. I haven't done much of that. I've downloaded additional packages, but I haven't done a really good job of learning how to maintain the currency of my environment because they do update these things from time to time. Particularly Python itself. I'm pretty sure I've got Python 3.7, and they're up to 3.9. So yeah, it's been 2-3 years since I did that. So anyway, yeah, that's it. And then there's, the download and install Anaconda, and that distribution will give you the current version of Python, which again is 3.9, as well as an integrated development environment, an IDE called Spider. Well, here I'm sharing my screen now. I'll go ahead and show you real quick here. Once you install it, you'll get an Anaconda folder on your start menu. Anaconda Navigator, like I said, that's your environment GUI, where it will show you the packages you have installed and what version. And I think from there you can do some updates, but most of the tutorials I see for updating your environment are actually in the Anaconda prompt, which is like a PowerShell or DOS or Linux or that command line driven, where you can update things, you can install packages and whatnot. And then yeah, this Spider here, it's similar to Eclipse, I think is the one Java uses, right? And Microsoft was Visual Studio. Is that the Microsoft IDE still?
I think so.
You think so? Me too. I think so. And Java, I know that was Eclipse a year or two ago. I don't know if any other IDE has Eclipse or not. But that was kind of the industry standard last time I knew. But the reason we are here is for this here Jupyter Notebook. And Jupyter Notebook is not strictly a Python thing. It evolved in tandem some, decade ago or so with the notion of using Python interactively. So you'll see IPython, which to the best of my historical Googling stands for interactive Python. And Anaconda is by far and large the most popular distribution or way to get Python. But this Jupyter Notebook, it's just a really cool environment. It cranks up a virtual web server on your workstation, and then allows you to use tabs on your browser to actually write code and whatnot. So I am sharing my screen, right? Everybody seeing my start menu?
Yes.
Got it, Kim? Okay. So yeah, you just click on Jupyter Notebook. And if there's some quirks, features, whatever you call it, considerations, phenomenon of working with Python or R. You can use Jupyter Notebook. I'm pretty sure they've got an engine or whatever, a way to link. I know they are because I did it. I was thinking of learning R, and then I'm not doing it. I started to learn it, and I was learning Python at the same time. It's just a few years ago. And R is so specialized in data science that I decided not to mess with it. So I'm thinking this. Yeah, there we go. It does take a little bit of time to pop up when you first run Jupyter Notebook. Good morning, Chris. How you doing?
Hey, good morning, everybody.
I was thought for sure we'd have Cameron finally checked in on email. He had a unavoidable appointment, couldn't get away from. But Dexter and Cam should be joining us. So anyway, when you hit Jupyter Notebook, it spins up a web server, and you'll get this window that is kind of like the log file of the web server. And whenever you do something, open something, close something, you'll start to see the effect here in this window. It's just like a confirmation. Although you can like shut down using Control C in this, but I don't use this window much. I just wanted to explain what it was so you wouldn't be distracted and curious. That's what that is the output from your you can see this hopefully where my mouse pointer is, HTTP localhost 888. It's starting like I said, a web server. I think it's an open source, maybe Apache. Anyway, that's what that is your server window. And then when it first comes open, when Jupyter Notebook first comes open, you're not this is not the coding environment. This is the Explorer, and it should open by default to the same level that you have your Explorer, your actual Windows Explorer, and you should see the same folder structure as you do, and it has similar functionality. You can create a new folder just like you would in Windows Explorer, so you don't have to have Explorer open in order to do just kind of file system stuff. Under this notebook, that's where if you have multiple environments, you can open a new notebook that is associated with an R interpreter. By default, it's Python 3 version, whatever. But like I said, I'm pretty sure it does Java. I think Scala. I've heard of Scala. Don't really know anything about it. But there's other. I mean, it's a quick Google away. There's other engines, compilers and whatnot that you can associate with Jupyter Notebook. So that's so I wanted to show you my file structure and recommend that you either in Anaconda or out in Explorer. I keep everything on OneDrive now so that it's there when I need it, when I'm on my laptop. Beg your pardon. Personally, ACDS uses a G drive. Google Drive. You might have seen links to documents and whatnot when you were getting signed up for the apprenticeship. But for personally, I use OneDrive. So under OneDrive, of course, we got the default documents, music, and pictures directory. I keep stuff for Python under my OneDrive documents, and then I got a bunch of junk. I'm sure I could be diagnosed with digital hoarding disease. I think it's common. People are worried that a link is going to go away or a file that they found out there is going to go away. So they store it on their computer as opposed to just relying on a shortcut to it. But maybe it's just me. Is it just me, or do you guys kind of hoard digital files and stuff?
I hoard as well. It's not good.
It's well, it's not good, but hard drives keep getting bigger and cheaper. So what the heck? But if you organize it, it's not as bad. Some of my directories are I really need to do some housekeeping. But here under my Python, you'll see uh, 4 directories that will potentially be impacted by the notebooks that we will use in this course. You see under my Python directory, I've got notebooks. That's where I keep all of the course notebooks. And the way I write them, I use a relative file location. So when I'm opening a data file or something like that, you'll see dot dot slash data, which is this directory here. So dot dot means go up one and then go into the data directory and open that file. Whenever you're working in Python, if you write something or read something, it defaults to the current directory, like wherever the notebook is that you ran it from. So just keep that in mind. So I recommend, if you want your notebooks to work right, is that at the same level as you create a notebooks directory, which is where I recommend you download the IPYNB files that you see on Canvas. Download those to notebooks, but also create a data directory, because we're going to put all kinds of, here, I'll click on that. There's all kinds of CSVs and text files and stuff that we'll be messing with. And then you can see up here, there's a path. So you don't have to, if you're down deep into some path, you can always click on the level you want to go back up to. So I'll go back up to, I don't know why I had, this is a notebook, IPYNB in my data directory. I might have created that there. Let's see. Normally, all my notebooks are in notebooks. So you will see, and the Canvas classroom is cleaner than my notebooks directory. You'll see I've got, oh, good grief, 1, 2, 3, 4, 5, 04 something or other notebooks. So don't get distracted by my horde here. Download the 1, 2, 3, I think it's up to 15 IPYNB files and download them into your Python directory, or your notebooks directory. So yeah, I've got just these 1 through whatever numbered ones are mostly associated with this course for different stuff I've done. But there's this was these 1 through 4 here. I think those were another tutorial I downloaded. Some of these I just named for what they do. And then here's a previous course, that DAAT10 March. That's from last year. Just a lot of project stuff I've done, some other lessons, stuff from my colleague, Mike Ellis. So yeah, this is shameful. I'm ashamed. I need to have a psychiatrist come in and analyze me. And there's some input and output stuff that I didn't bother to be disciplined and put in either my TMP directory or my notebooks directory or my data directory. So anyway, there you go. So that's when you first come into Jupyter Notebook, you have an Explorer. But the real magic is when you create a notebook and write some Python code. So like I said here, you can do a new notebook, and I'll click on that, and you'll see bare bones what a new Python Jupyter Notebook looks like. It comes up, and this is a tab in Chrome. It's untitled, so you can click there, give it a title. And it comes in, Jupyter Notebook uses cells, code cells and markdown cells. This is a code cell. All y'all have some IT, so you'll recognize we'll go into this in more detail. So you type in a line or 500 lines of Python code into a code cell, and you can run it. And of course, bam, hello world. And you can tell that a cell is either code or markdown by 2 ways. The color, or in the drop-down menu, you can change the type of code that it is. Heading, that looks new. I don't remember seeing that before. Huh, a heading cell. Interesting. I'll have to goof around with that. That might have come in the last time I did update Jupyter Notebook. Anyway, there you go. So you can create a new Jupyter Notebook from scratch just by from the navigator saying new. Okay, so I don't really need that. Let me put that away. So when you're closing a notebook, you always say file, because each notebook has a separate instance of the interpreter, and each tab in Chrome will have a separate version of the interpreter. So you have to shut each engine down. So we say close and halt whenever we want to, and you can leave safely. Okay, so let's do 01 Intro to Python and Notebook. And that is, again, that's in your Canvas classroom under the Python area. So I do have to give a shout out to my colleague at the University of Central Arkansas, Mike Ellis, Dr. Mike Ellis. He's a computer science instructor, faculty member, professor in the College of Business. So he does more management information systems, business statistics, data analysis, data science with Python, those sorts of things. So these notebooks are helpful to someone that doesn't have a computer science degree. Chris, I apologize. I know some of you guys have MIS or computer science degrees, so I won't belabor it. But there's some helpful hints in here. So yeah, this is Notebook 1, Intro to Python and Notebook. Once you get into here, you'll start to see these different cells. Like if you click on here and you see blue, and up here it says Markdown, you can tell that's a Markdown cell. And these first ones, it kind of highlights them as you click. You can tell that it renders it. It makes it kind of hard to see the individual cells unless you start clicking in there, because it makes it pretty. You don't want to see cell breaks, because these things can be printed out like a PDF and be published as like analysis project documentation. So you don't want it goofy looking like with different cell boundaries and everything. So generally speaking, these markdown cells will render without any borders, and they look pretty nice. So yeah, each notebook is made up of cells, and we're going to use code and markdown. I'm going to have to try. I'll mess with that on the break, maybe a heading cell. So we're going to use code and markdown. And out in the classroom, you'll see there's a markdown syntax that shows how to do it. If you're just typing, you literally, to make this text, you just type it. That's the default, and it'll come out in the default font, which can be modified. But then you'll see there's a special formatting syntax, *** underscore, and then a word, underscore *** is for italics, and there's one for bold. There's a whole language for doing like mathematical expressions. So if you really need to document the formula for something, and it's like, the quadratic equation or something crazy with, square root or whatever over something, and special symbols and mathematics and whatnot, there's an entire language for that, that I'm sure we'll talk about a little more as we go through the course. So that's what happens when you double click a markdown cell, is you see basically the source code. And then to run a cell or execute what that cell, the code or the markdown, you can do Control Enter, which I wind up using a lot, or you can move the mouse up here to run. And then we'll get into these menu options. There's you can run everything in the notebook, or you can do stuff before where you're at or after where you're at. If you've done programming before, as I had when I first saw this, and this is really my only exposure in as far as training is concerned to Python, is in these Jupyter notebooks. I've never really worked with an IDE much, although it looks just the same code. It's just a different environment. But coding in a Jupyter notebook is different. So we'll cover that. So yeah, markdown cells, and then like let me double click on this. Like one hashtag is a level 1 header, then 2, 3, 4. There we go. I've never met. Do you see a pattern here? That's my man Mike's sense of humor. He's loves goofing around, having fun, and Python is named for Monty Python. Did you all realize that? All of you? If you didn't, come clean and admit it.
I had read that.
Yeah, it took me a click or two. I'm like, I had heard about Python for, I don't know, a couple of years before I even bothered to learn anything about it. And yeah, it made that clear the first day. And I'm like, there you go. That makes sense. So for any computer programming language developed and extended and used enthusiastically, that's named for Monty Python, there's going to be, some joking around. So there you go. So like I said, there's a cheat sheet for this markdown language in the Python section of your Canvas, so you can get to know that. But I mean, I use it a little bit here and there, mostly the formatting, the italics and whatnot. And sometimes if you do code, Python will get confused, so you surround it by tick marks. And anyway, there you go. So that's how you get this pretty well formatted executive consumption level documentation for in Jupyter Notebook. Okay. And then yeah, bulletized list, you just use dashes or numbers and it automatically picks that up. And you can insert images, which can help. And I've even seen a GIF that with motion inserted into a notebook, and it renders it and puts it in motion. So if you have something that highlights a process and it's animated, like data comes in here, wugga 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 goes out there, or something, any image that is animated that helps with your documentation, that'll also render in a Jupyter notebook. But since we're all programmers, the most important thing is a code cell, and that's what pops up by default if you need a new cell. So there we go. You click in there, and well, now I want to do something that you will commonly do here, and that's clear everything. When you've been running this, you run the code and you get the result right after that code cell. Well, sometimes it starts to get messy and you just want to start over again, clean, as far as the output is concerned. So you can come up here and you can say cell, all output clear, and that will get rid of the results from all of these code cells, which I thought I did that when I posted it. Have any of you downloaded that 01 IPYNB? Are any of the 4 of you following along?
I'm on it right now.
Okay, Edgar, were the results already there, or was it
No,
cleared out?
It was cleared out.
It was cleared out. I thought I did. I try to do that. Remember, every time I update and upload one so it's not confusing. So yeah, click in hello world, and of course, and control enter to run that. But of course, this is the joy of Python. It's pretty straightforward. The language is super simple. Like I remember my son Eric, he works in the same building with Seth. He attended the Arkansas Coding Academy boot camp where I was the director, and so I got a kind of a firsthand glimpse into what he was learning with Java. And I've never, I mean, I've seen Java, but I've never really taken the time to learn how to do anything with it. But they use that for the teaching language in a lot of programs. I know they do at UCA, even though they're gravitating over to Python. But Java is the object-oriented language of the internet. So, I mean, you know, it's a solid choice. But just printing something in in Java was a pain in the butt. It's just not made. It's just not friendly for doing console stuff like this, console apps, as much as Python is. And that's where, like I said, that's the I in IPython that you'll see out there, interactive Python. So it's really designed now to be something that you can, you know, do a line of code here, do a line of code there, and actually do short little programs and see the output without having to write an entire application and then running that. It really is made to do snippets of code incrementally as you go along. So I went ahead and entered that text into the cell for you guys, so you can cut and paste, or you can, I should have cleared that out. Okay, so we're saying my bar is equal to 3 plus 4. There's some folks that have a little less coding experience than others. That's what's called as declaring and assigning a value to a variable called myvar. So for the life of this notebook, after we run this, myvar will have a value of 7 in it. So I may get ahead of myself here, and if I do, I'll just skip over when it comes to it. But one of the notebook isms that's really weird if you've only worked in an IDE is the concept of these code cells. You can see the 1 next to the code cell here. That means that means it's the first code cell that I executed. So in the execution sequence, that's the first one I executed. And then this one's down here. It's not a line number. You can enable line numbers if you want to be able to like talk to somebody and say, hey, on line 12, I got a problem with something. Actually, they are enabled. That's what the 1 and 2 in this area here is. Hopefully you can see that. But in the square brackets, that's the order in which the cell was executed. And that matters because sometimes you'll run into a clean notebook that you've been working with before, and you've got code snippets that you've written in order. And sometimes you're like, you run down to the bottom and you run a cell and it barfs because it kind of depended on the code before. So you just have to remember that. It doesn't matter to Jupyter Notebook. It doesn't matter what order the code cells are in. It matters what order you execute them in. And generally I execute them top down, but it's just something to remember. It's a phenomenon of working in Jupyter Notebook versus in a straight script, working with just straight scripting Python. Okay, so yeah, right now myvar has the value. It does the math on the right side of the equal sign, and that can be super complex, or it could be something really simple like adding 3 and 4, and assigns it into myvar. Myvar is now a variable or a location in memory where the number 7 is stored. And we'll get into some more Pythonisms that can be confused. But are any of you seeing Python for the first time?
I am.
All right, Chris. But you've seen other programming languages, right? You've got to.
Right.
So what's the first thing you're noticing maybe that's a little weird about this code cell 2 compared to other programming languages you've seen? Now I'm putting you on the spot, but let me pick on you.
I'm not super versed in coding. My background is more so business, so I couldn't tell you honestly.
Okay.
I've done a couple computer science course back in my undergrad, like C++, but that's been years ago.
Okay. Well, I'm picking on you, so thanks for letting me pick on you. Okay, so what freaked me out, and that I had no idea was even possible, is that Python is dynamically typed, and you can create variables on the fly. You don't have to have a declaration section, which I learned, no kidding, cranking out code in Pascal 34 years ago. And you declared a variable. You couldn't assign a value in your code to myvar without telling the Pascal compiler that I'm going to use this memory location called myvar, and it is an integer. And if you tried in your code, as a programmer, if you tried to assign a non-integer value to it, it would barf on compile, let alone it would never run. So that's the other thing, is if you haven't worked with an interpreter before, this can be a little counterintuitive. C++, you compile the code into machine language, into a .exe program, and then you run it. Python, as an interpreter, is like, I don't know if they even use it anymore. Basic. That was, a language going way back, 70s and 80s. Yeah, but it made its way. Visual Basic made its way into the modern world. But anyway, yeah, Basic was an interpreter, so there was no steps involved. It read line by line and executed, and all in one go. And Python's the same way. So of course, because it's interpreted, and it has to do the interpretation and then the execution of the interpreted code in one step, it can be a little slower in execution than Java, or certainly C or something like that. But it's written in C, so I'm told. C++, internally, the guts of Python. So anyway, there you go. There's a code cell. And you can print myvar. There's two ways to get output to the console, which is to the screen. You can print and then pass the variable that you want to print as a parameter to the print function, or you can just type the name of the variable. But there are notebook isms to that, that you want to be aware of, and we'll go through it. If you just say myvar, and then you have another line where you want to see the contents of another variable, and you use that variable name, the second one will overwrite the first one. So you'll only see the last variable, that name that you typed in there. So I generally just, by default, when I want to do a diagnostic statement and see what the value of a variable is, I say print, because print will automatically do a new line, and every print statement you'll see the output of it. So that's the print function. That's the term. That's the Python word for a command, or a built-in piece of functionality is a function. And you can do multiple parameters to the print function, separated by commas. So I'm printing in that command, I'm printing the contents of myvar. I'm printing the string literal, hey there, and I'm printing the numeric literal, the numeral 9. So if I run that again, the output of that little 7 underneath that code cell goes away, and we get the new output from that print. And it also it's rerunning that assignment statement, which can be inefficient depending on how much processing you're doing. You want to get a new code cell and not rerun the same chunk of code every time just because you made a little change. We'll get there. You'll see what I'm talking about. So I'm going to rerun that and we'll get a new 7. Hey there, 9. And just because I see this happening occasionally, especially when for folks that are new to coding, there's a difference between my var and my var in quotes. My var not in quotes is Python will be looking for a variable or an object, something of the name my var. But if you put it in quotes, it's just the string literal, and it doesn't look inside of a string literal to determine anything. So we can run that again. Control enter. 7. Hey there, 9 my var. So that's your print function. You'll use it constantly. Let me get rid of all this junk so that when I save it, that's another thing is if you see something weird, it could be because I saved junk and didn't notice it. Okay, so yeah, down here, when we execute this cell, you'll get 7, but here we go. I'll get there eventually. But if you have, like I said, if you have more than one variable there, it would overwrite and you'd only see the last of these. But this can be handy, like instead of printing the value of variable, you can see what is returned or what the value of like, and I do this more later. So 1 is greater than 2. So what are you thinking would be the output of that? Edgar.
What would be the output?
Of 1 is greater than 2. Yeah, if I type in 1 greater than 2, what would you expect to see for the output?
Maybe an error?
You would think, right? But no, what that's doing is if you just type in something in Python, it evaluates it and gives you the result. That's why when you just type in my var, it's evaluating my var and it goes, oh, well, that's a variable and it's got a 7 in it. So here, 7. But when you type in something like 1 greater than 2, it's evaluating that expression and giving you the result. And as we all know, 1 is not greater than 2, so you get false. So it's easy to see that functionality is handy if you wanted to test a condition that, like a complicated mathematical greater than or equal to this or that, or what. If you wanted to test it to see what the result would be, you could just put that expression as a line of Python code and it would evaluate it and give you the result. So there you go. How are we doing? Break time. I'm going to continue with this notebook and finish it up in the next hour. And then I wanted to go into the business question thing before we talk about specific data. And guys, I go slow with the course. We'll get to some magic. Please don't get bored with me. But I want to be thorough, and we have everything from folks with a computer science degree to no coding experience and everything in between. So I just want to make sure that I speak slowly and deliberately as to not confuse people, because I've had the opposite type of instructor and it's maddening. So I err on the side of slow and boring. All right. Any questions on what I've done? Did I confuse anything so far? Realizing we're just getting started. Any questions so far?
Hey, Don, I was just wondering, why do you have out 6 there on the bottom one, but no out statement on the top one? Like, what's that about?
Let's see. That 6 is every time I run it, it's going to increment that because it's the 6th. And if I run the same cell, it's going to say this is cell number 7. Bam. Why? Oh, I got you. Because I used a print up there. That's another ism. of the difference between using a print statement and just using that and doing that, just an expression. Yeah, let me rerun this, and this will become cell 8 now, or execution sequence 8. But again, there's no output line number. When you do this expression, you get this additional, and I've never seen it not match the input. So good question, Seth. But I don't think it's nothing I've had to mess with and I'm an advanced beginner Python programmer. I've never had to worry about it. But I'll try and Google that.
Okay, yeah, I was just curious.
Yeah. But dude, I need to look it up. I should be able to speak to that. And I don't know what it is. But I know there's so much I don't know. You could fill volumes. Okay, so when we get back, we'll move on with the print statement. So yeah, 9:18. Let's back at 9. Let's do 9:35. 9:35 cell phone time. And if I forget to pause the recording, holler at me. All right, welcome back, y'all. Good morning, Dexter.
Good morning.
How you doing?
Pretty good. Who got off?
We're going over Jupyter notebooks and Python. A lot of this stuff will be familiar, but there are some oddities when it comes to working with Python, and then further oddities in Jupyter Notebook. Have you worked in Jupyter Notebook with Python much?
No, sir. I did the crash course with you, but I haven't been working in it.
Okay. Well, a lot of this will seem familiar then. All right, share screen. So we were looking at this here notebook, but I wanted to bring up the console. And you can see what this thing is doing in the background. When I did that close and halt, about 12 lines up here from the bottom, you can see kernel shutdown. That's what it calls each Python engine, is a Python kernel, kind of like a kernel of an operating system. And then when you open a notebook, it says kernel started, and then it auto saves. I think it's by default every 2 minutes. And of course, you can hit the floppy disk and override that and create a checkpoint, a save point. But this is the console going, with what's happening kind of in the background with your overall Python environment. All right, so back to that notebook 01, Intro to Python and Notebooks. So again, yeah, I need to delete this code cell. I keep forgetting to leaving this in here. So Control Enter to execute this, and you see the string literal. This is a good format for showing the user something. A string literal colon space, that's a pretty good convention for that. And then it shows you the value inside of my bar. It resolves any expression that's not a string literal, inside of that print function. Okay. Let's see what, and again, my colleague Mike created these notebooks, and I use them every time. So they're really helpful. So running the code in cell, added demonstration shows you powerful features of notebook. Yeah, when you're in a notebook, which is a tab, the tab on your browser, anything you do, the variables you create, the values you assign, is global to that notebook. So if I do I'm sorry, cell, I think that's how you get a new cell. Oh no, plus sign. Yeah. The plus sign is how you insert a new cell below. So if I wanted to do some more code and I just needed a blank cell, the plus sign will give you a new code cell immediately below the cell that you're in, whether that's a markdown or a code cell. Plus gives you a new cell. So in that other cell, it's not like these things are individual programs. The entire notebook is like a program. So for the life of the notebook, any variable you declare is visible in any other code cell. You just got to think about the order. Did I do that yet? Doesn't matter where it is in the notebook. In order from top to bottom, it matters what order you executed the cell in. So we've already declared myvar, so we can use it in this code cell. So we can say print myvar is, and then myvar. But I want to show you that if you try to use a variable that doesn't exist, you will get a slap on the wrist from Python. Print your var. If I run that code cell, because it's an interpreter, it executes the first one. You see, we got the my var is 7, but then it errored because there is no your var yet. So just keep that in mind. So my var is available throughout this notebook as you're working on problems. And once we get going on some hands-on exercises next week, you'll see what I'm talking about. Okay. And yeah, when you want to, actually, I want to delete that. So I click in that code cell and scissors cut selected cell. And I want to get rid of that because next time I want them to actually type that in, and they don't need that code cell. Sorry guys, I'm doing a little cleanup on your dime. So saving and closing a Jupyter notebook. You can hit the floppy, like I said, and they call it a checkpoint. You see up here, last checkpoint, March 15th. That's not very granular, but anyway, if you hit the floppy disk, that whole save early and save often, it'll go ahead and there you go. Last checkpoint a few seconds ago. That's a little more meaningful. But generally, when you want to put away a notebook elegantly, you hit the floppy to checkpoint, and then you say file, close and halt. I'm not going to do that just yet because we're still reading what's going on in here. So there's quite a bit of functionality in these menus. Some of it you use more than others, like the view menu. Toggle header gets rid of that. Get you back to the name and whatnot. Toggle toolbar. You almost always want that toolbar on, so I would never turn that off. And like I said, when you have more than one line of code in a code cell, 1, 2, you can toggle line numbers on and off. They're on by default. If it starts to get crowded visually and you don't want them on there, you just hit that and it turns them off. And it seems like these defaults to the next notebook that you start. Let's test that. New Python notebook. So in that other notebook, I said turn off line numbers. Line 1. So I started a new notebook by just saying new over there in my Explorer. 1, 2. So I did. I toggled line numbers off, and now they are off in your Jupyter Notebook environment. So so those preferences that you do, Control Enter, extend or persist throughout the notebooks. So once you set something, after that, all your notebooks will have that same appearance. Let's see. Don't want to keep this one, so I'll just say file, close, and halt. And there's probably going to be a bunch of untitled notebooks down here in my in my area. Oh, good. No, yeah, untitled 1. Sure enough, more clutter for the horde. Okay, so yeah, other cool things. I don't mess with the kernel here on the kernel menu. I don't mess with that, but it seems like one time I did. I think I said, restart or shut down, because I wrote myself an endless loop where you get a logic error and it just sits there and cranks. When a cell is executing, you'll see a star instead of this number 7, this execution number. While it's executing, you see an asterisk, and that means it's executing. Well, if you've got a logic error, it will asterisk forever. And you can use the kernel menu, and this is really more if you really get into Python, you can restart the kernel, you can stop, quit trying to execute. There's some other, now the cell menu I use frequently, like if you like this notebook, if you wanted to just run everything from the top and run every code cell, you click cell run all, and that will run every cell from the top to the bottom in order, without you having to click in each one individually and run them. You can change the cell type from the cell menu. Like I said, I use this current outputs, all output. I usually say all output clear when I want to get rid, because it gets messy, particularly if you've got error messages. They can get to be, a page long. So I'm frequently clearing output, all output. So there you go. Yeah, that's the environment you're in. And it couldn't hurt if this is something that you think you're going to want to get more and more familiar with, and you're going to actually do some work outside of class. It could not hurt to watch a 20-30 minute YouTube video on Jupyter Notebook formatting. There's some of you probably like your computer to be set up with a dark background and light text. They say it's easier on your eyes. I can never get used to it. It's so different from what I'm used to. But you can change themes and stuff like that for your Jupyter Notebook. So there's other stuff you can do. And I don't know much about them, but this widget thing, it can be helpful. So like I said, I just do the bare bones for the class. I don't get too much into it. But if you're going to be using this environment frequently, there's tons of information out there. So yeah, Python in the notebook. Here's some good rules of rules of the road from computer science, and this goes for for any programming language. Readable code. A good program is an essay solving a problem that just happens to execute on a computer. So it's really more important when you're writing. What that means is when you're writing code, it's more important to make it readable for the next person that's going to look at your code than it is to be gee whiz with the language. And even for yourself, I mean, I've come back to programs if I was just cranking away and not really worrying about the readability and the maintainability of the code, it's hard to figure out what in the heck I was thinking. So there you go. Writing readable code so that everybody understands what's going on is important, and that's especially easy to do in Notebook because you can write a markdown cell that documents what in the heck you're doing, but you can also put non-executed comments in your code like you can in any other programming language. Plan before you code. Yep, that's always smart to sketch out, particularly anything that's complex. It's got a lot of if then else logic or looping in it. Plan, design your solution before you start coding. It can be really tempting to, I don't know about you guys, but it's really tempting for me to just jump right in and hack it out and just make it work. But thinking about how you're going to approach the problem, always a good idea. Yeah, and getting good at this stuff. I wish I had more exposure. Practice. If you're using these tools on a daily basis for work, you definitely got a leg up on somebody like me that just uses them for teaching and the occasional project. You'll hear me mention conventions. That's just it's not a tried and true rule or anything like that, but it's just the way folks do it, and they exist for a reason. And that's so that everybody knows what in the heck you're doing. And like one convention you'll see is Python uses a whole lot of libraries instead of cramming all this functionality into the base language of Python, which would cause it to bloat a la anything written by Microsoft. They put them in libraries that you only pull in when you need. And one of the conventions that you'll see is that there's a short name for most of the popular libraries, like pandas. That's the one that lets you work with stuff like a CSV file and do cool stuff with columns and rows. Whenever you import pandas, you alias it as PD. That's a frequent convention you'll see. Import pandas as PD. And then whenever you refer to functionality within pandas, you call PD dot functionality, not pandas dot functionality. So it's for brevity. If you're a C programmer, you love brevity. So that's what that's there for. Yeah, testing your code, test it again. Almost all the code we will do in this course will work. We'll get it to work, but it's definitely not error proofed. I don't even go into exception handling or error proofing code really. We'll touch on it, but most of what I do is just to teach the functionality and it will work. Like, enter a number between 1 and 10, if then else this, you'll get it to work, but there's a whole nother science involved with writing code that won't blow up if somebody puts the wrong value in it. Yeah, all input is evil until proven otherwise. Validate input, which is smart. You can loop as you're asking a user to put in a value. You can loop, stay on that until they put in something within the bounds of what you're expecting. If you've done any web development at all, a lot of work goes into validating input data. A function should do only one thing. You can write your own subroutines in Python. And if you do something, if you write a chunk of code that calculates something or does something more than once, or it does something that's complex, it's often smart to move that out into its own function where it can be called in your code. You can just use that one, like the print function. You can just use one little line of code that does a bunch of stuff. instead of doing that bunch of stuff 10 times within your code, it just makes things more readable. And the more, what do they call that? The more nuclear, the simple that your functions are, the better they'll be. The more readable they'll be, the more easier they are to troubleshoot. When the rules change for what that function does, you change it in that function and nowhere else. And then wherever you use that function now, bam, you've made your change. So that's just a good rule of thumb. A good convention is to make them as simple as possible. The language standard for the Python working group is on this link here. That's the other. You can insert hyperlinks into a markup. Insert. No, there's a way to do that. I guess it just recognizes that it's a proper link. So that's the language standard. But it's complete and it's accurate, but I never go there for help. There's a few other ways to get help. You'll see there's the help menu up here that will pull up the official references for Python, and then these are libraries like NumPy is a really popular numbers library. There's other ways to get help. We'll cover those as we go along. But I normally go out to Google, and I've had really good luck. There's a website called W3 Schools that does really good examples and tutorials of how stuff works. If you're a coder, Stack Overflow is the discussion board where people ask questions and get, but you get what you pay for. Some of the input is good. Some of the answers you see are better than others. So I like a good tutorial more than I like Stack Overflow, but some of the more complex stuff you can only find on Stack Overflow. So anyway, that's about help. So back to computer science. It can be easy when you have a problem to solve. It can be easy to get intimidated. But there are really only 3 types of statements in any computer program, really. There's sequential statements that just line by line by line by line by line, as we saw up there, declaring a variable and printing it out. It's going to execute from line 1 to the end without thinking, if it's all sequential statements. And then we will go into decision statements, logical operators. If then else is the logic. But those can be very simple. If age is greater than 30, print you're older than 30. But we'll do the syntax for Python the way Python does, single, double, and then multiple conditions. And then you got repetition, where sometimes you want to do something a limited number of times. Sometimes maybe you want to run a simulation 20 times. So you'll use the traditional for loop in Python to loop a predetermined number of times. And then you'll use a while loop to loop while a certain condition is true. And then as soon as that condition is no longer true, it pops out of the loop. So you've got all the normal constructs in Python. It's just getting used to the syntax. And if you haven't been in, coding for a while, it can help to have some practice. So yeah, just basic stuff here in these other code cells. Good old print statement. If you want to print an extra blank line, just print quotes with nothing in it. Again, variable is a named memory location. I don't want to get into it too early. You will we'll get into if you've had computer science recently, there's a notion of pass by reference and pass by value. We'll get into that with Python. It's particularly weird. And we also got to talk about data typing. The craziest thing, we're talking about Python, you can just use a variable without declaring it first. It goes ahead and assumes the data type. Dynamic, so it's dynamic declaration and dynamic typing, which and then if you reuse that variable, say you declare, the first time you use it, you set it equal to 7, it'll assume that it's a data type of integer. And then if you try and do something with it that it doesn't like for an integer, it'll error on you. But if you can turn around and now say my bar equals quote Don Walker, and it goes, oh, okay, my bar is now a string, which is just mind blowing if you're an old programmer like me and you've never worked in that environment before. But it sure does speed up the hacking. I mean, you can really hack something out really quick because Python does not object like other languages, in my experience. So we create variables and assign a value to them with one equal sign. You'll see when we start doing if then else, 2 equal signs is the comparison operator. But 1 equal sign is the assignment. So here we've got think about it. Can be really tempting to say X or Y or whatever, for a variable name when you're really just trying to get the code to work, but you won't know what in the heck you were doing if you come back to it, a month later or somebody else reads it. So meaningful variable names are important. And then, you're all in an organization. If you've got much of a software organization at all, or a data analysis organization, they're going to have naming conventions. So we'll run this cell and you'll see the results of these. Sales tax amount, print sales tax amount. Why is that twice? Why are we not printing tax? Again, sometimes I'll goof with these notebooks. Let's run that again. There you go, 3.41, 3.12, there you go. And then we did a little bit of math for sale total. And you can see it starts to get a little more complex here. And Python uses what looks like the absolutely standard mathematical operators like what you see in Excel. So you're using, star for multiplication, slash for division. You can use parentheses to override the normal order of operations, which usually uses, multiplication first, then division, and then addition and subtraction. So you can override that with parentheses, plus for plus. So it looks a whole lot like you would expect. Pretty intuitive, a lot like Excel. So there you go. And it automatically assumed I don't think we numeric data types. Yeah. If you declare a variable with an integer type, it will assume it is a data type of integer. If you use a decimal, it will assume it's a float. And those there are rules involved when you're using certain functionality, certain functions, particularly if you pass an integer when it's expecting a float, and vice versa, you can get an error. So it's kind of important to understand what the variable is. And you can check the type of anything by using it. There's a type function. You pass it a variable and it will return the type of that data. We'll go through some of that. Okay. Numeric data types, and then there's a string data type to include a single character. Some languages have a char, char variable type, which is one character, which will bomb if you try and put more than one character in it. But a single character in Python is still a string. So we can declare that first name is Arthur, King of the Britons. And then we print those two. So looking at this, let me pick on somebody. I want to make sure I'm not talking to myself. Seth, you still with me, buddy? I saw your mic come off mute. You still there?
Oh, sorry. Yeah, I'm here.
There you go, buddy. Okay, so if I were to print this print line, what exactly would you expect to come out to the screen?
Arthur and then King of the Britons.
Correct. Any I'm picking on you, but I'm not picking on you. In between Arthur and King of the Britons, what would you expect to see?
I think you'll get a space here because it seemed to add a space between.
Awesome.
Normally.
You are
and,
correct.
previous stuff.
You are correct. When you print a list of parameters, the print function automatically sticks a space in there, which you may not want. So just remember that when you do multiple parameters, when you print multiple parameters separated by a comma, you'll get an additional space. Arthur, King of the Britons. I'm stealing my own thunder, but if you wanted to literally print them smashed together, concatenated, you can use the plus. And even though those are string variables, it will concatenate them together. So Python knows not to try and do math with strings, which other languages will barf, right? I mean, you can't add strings in I don't know, not in Pascal. Anyway, so we'll run that, and now there's no space between Arthur and King of the Britons. Just something to keep in mind. And there's a couple of other things I wanted to point out here. Oh, the comment character is pound sign, hashtag, and you can put a comment on a line with code so that it'll ignore anything after the pound sign, or you can put it in its own line. And there's not really an accepted multi-line comment character in Python. So the convention is to use a pound sign in the first character if you wanted to do multi-line comments like that. If you needed to code a comment block, you just put the pound sign in the first character of that whole of every line. All right. Okay. Performing calculations, like I said, just like Excel. Modulo is percentage. That's the remainder. Slash, I think truncates. Yeah, gives you the result by truncating. So a lot of times you want to check to see if something is even. You do mod2, the variable mod2. So yeah, modulus is useful. There's like I said, it's dynamically typed. So the data type of the variable matters when you go to use it. So there's a function to convert any data type to int, float, or string, so that it will behave the way you want it to. And there's also a type function that if you need to check the type or print out the type of a variable, there's a function to do both of those. And the int function truncates, it doesn't round a floating point number. So it would convert like 8.3. If you wanted the int of it, it would be the integer portion. So it would be 8, and it would convert that to an integer data type. Okay, so right now, in a previous, remember the global nature of these variables. Back here, we declared sales tax amount, and it's defaults to being a floating point number or floating point variable because we, when we declared it, we used decimal place. So down here, we're going to print sales tax amount, and then we're going to print the int. We're going to send sales tax amount to the int function, and then send the results of all of that to the print function. So you'll see that a lot, nesting functions like that. And then one last time, we'll print sales tax amount. So you see the int function does a temporary conversion. It doesn't actually convert it. It only returns the integer portion to print. If you actually wanted to convert it, you would have to make the variable, you'd have to do an assignment statement. You'd have to say sales tax amount equals int sales tax amount. And that would make the change permanent. And the same, like I said, there's an int, float, and a str function that will convert stuff. So what should this statement equal? Hopefully you haven't run this already. When we do 12 times usually do multiplication first. Actually, exponentiation first, right? So 3 to the second. 3 squared, that's 9 times 2, 18. And we do 6 times 3 is 18. So then we do 12 minus 18 plus 18. So 12 minus 36, so negative 24. Did anybody guess? I hate these things. Just run it.
It'd be 12.
It would be 12. It's 12. There you go. Did you do that in your head? You run it, Edgar.
No, I cheated a little bit.
Honest, that's good. Me too. Like I said, I would use parentheses because they don't cost you anything. They don't affect but just to be clear in my head, what's happening first, I would normally put an unnecessary parenthesis around the multiplication and the division just to make just to get it right in my head. So yeah, 16 divided by 4. Okay, so 12, that's an integer return. And it provided that. 16 divided by 4, 4.0 is a so it defaults to a floating point. Even though it's an integer return, division returns a floating point type variable. So then we printed temp int, and the type of temp int is a float. So just, that's what I say, when you're hacking away, unless you're really, in it all day, every day, you wind up using the type command, the type function, which is what we see right here on this line. Print the type of temp int. The first time is float. And then we pass temp int, like I was saying before, to the int function, and it converts it. Temp int equals int of temp int. Now temp int is an integer. And when we print out the type of it, we see that it's now changed to being an integer. So it's just something, I mean, if you've, if you've used other languages, Python typing is something you got to pay much more attention to than you do in other languages. There you go. So again, these are sequential commands, right? It's gonna, when you execute a code cell here, there's no if, there's no then, there's no loop. Beg your pardon. My phone's turned down, but it's buzzing in my pocket. It's going to execute from top to bottom without any condition. And then whatever it ran is available anywhere in the, anywhere in the notebook. If you do a new notebook, none of that's available. Let me prove that to you. So we've got my var that we've been using, right? So if I go over here and I do a new notebook, and we get the usual single code cell. If I try and print my var, please don't prove me wrong here, barf. There is no my var in this notebook. So that's where the global nature of variables in a Python notebook ends. It's within that notebook, not because it's a separate instance of the interpreter for each notebook, which you want. If you've got 6 notebooks open that you're running from off the internet, you don't know if they're using the same variable name. So there's no way you would want it, I think, to be different. So file, close and halt, get rid of that unnamed, another untitled. Okay, so here break even quantity, there's your break even fixed cost, and we're truncating the remainder. Selling costs, variable costs, fixed costs, bam. So our break even is 40. We got to make 40 or whatever those are. Kind of rushing because I want to go on break. Yeah, here's the concatenation character. So if you use the plus sign within a for strings now, inside of the print, it will take away that extra space, or it won't insert that extra space. But if you print 1 + 2, it's going to print 3, because it'll do math on the numeric literals inside of the print function, but it knows not to try and do math on strings. Okay, they can be run independently, but everything that has already run is loaded in memory as variables and values. Variables can vary. Thanks, Captain Obvious. And that's why they call them variables. Sometimes there's a magic number you might want to declare, and there's no way in Pascal there was a data type called constant, and you could declare a constant, and then no programmer subsequently could screw up and change the value of that constant that you had declared. They could only change it up in the declaration section. There's no way to do that in Python, but your work might have a convention, or good practice is to use a constant, use a variable with that magic number in it, like sales tax rate, because you want to declare that one place and then not mess with it in any of your subsequent programming, because if it changes, you want to change it one place, and then everywhere in your code you're referring to the sales tax rate, which in this case is 0.0885. So that's the concept of a constant, and we got a little paragraph on there thanks to Buddy Mike. One last programming example. Here's some more code examples. So we got a shipping charge that we're declaring as a float, a discount rate that we're declaring as a float. Cover price of a book is 15, quantity is 50. So now we're doing a little math here, quantity times, and then parentheses where you don't necessarily need them. I would always do that. But then here's a good example. We're printing total order price is, and then the order price. And then we're using that, we're just typing the variable name of quantity, which we declared to have the value of 50, and cover price, which we declared to have a value of 15. So if I remember correctly, when I run this, the print statement will come out on its own line and automatically kick you down to the next line in the output. Quantity is going to print, but then cover price is going to come and overwrite the top of that because you're not using the print statement. It's just, I never do this. I don't ever, when I'm programming, and I do a little bit of Python programming, I virtually never, ever do that. It takes a little bit more time, but I almost always use the print statement. So I will leave that up to you. Like when you're doing diagnostics, a lot of times when you're in a complicated program, you want to see on the screen what's going on, and you got to put in a print statement so that you can see what is happening inside your algorithm. And just doing this variable name thing just doesn't cut it for me. So there you go. Yeah. So the print statement worked. But then we get this weird, Seth, like you were asking, because we're just using the variable name, we get this weird output line number thing next to the 15. And like I said, quantity has been overwritten by cover price. So just keep that in mind. Okay. And don't forget, you need to shut down a notebook in an orderly fashion. So for me, I want to put this away clean in case I ever email it to somebody or whatever. So I want to say cell all output clear, and that gets rid of output good and bad question. It gets rid of everything. It resets the actually, no, it doesn't reset the counters. I want to check that. I almost misspoke. I want to be sure here. If I print hello world, that should be like 18, 20. Yeah. So it all output clears the output, but it doesn't clear what, it doesn't clear the notebook, as in like clear declarations and clearing variable values and all of that. But it does, yeah, it gets rid of the line numbers and the output and all your error messages and all that. So I like to clear that out, and then I create a checkpoint. Last checkpoint 39 minutes ago. Huh. Could have swore it saved every 2 minutes. I have to look into that. So hit the floppy for change, and then file, close, and halt. And then when you get back out to your Anaconda Navigator, you still have this going on, right? So remember, save, kernel shut down. That was when I just did the close and halt. That's what that command is right there. When you get out to, you've closed all your notebooks and you're all ready to stop working with Python and Anaconda, you say quit at the top level. You don't close and halt once you get out here. And once you say quit, it will kill the virtual web server and everything, and close out the environment. And it'll give you this little message: you have shut down Jupyter. But it won't close the tab out for you, but it's useless. If you tried to do something now, it doesn't have the environment open anymore. So you just close that tab. And that is my quick tour of Python in Jupyter Notebook. And subsequently, we will cover the language more, thoroughly. You'll see in the classroom, there's several notebooks working up through, if then else, and some languages have a case statement. Python uses elif, if something, elif something else, elif condition 3, elif condition 4, else would be like the final condition. So it uses a if, elif, else. You'll see people writing about that sometimes. And we got another notebook for looping, and we'll talk some more about data types and the functions and manipulation and all that. But that's all the Python for this week. I got one more PowerPoint I want to go over after the break. and I want to bring up the business question assignment, and go over that, those instructions in detail, and then give you some time back in your day to work on business questions. And I'm hoping that you'll use that time and go to excruciating detail for me on the business questions, and then the subordinate business questions, and where that data is coming from, what type of database, what data types, whether it's clean or not, how much data cleansing do you do, all of that sort of stuff. The more I know about what you're going through, the better I can shape future discussions and use examples that matter to at least one of you, if not all of you. Okay. Any questions on what I covered so far?
No questions for me.
Chris, how you doing?
Pretty good so far.
Okay. Kevin?
Oh, no questions here.
All right. Dexter?
No, sir, no questions.
Tracking okay? All right. It's 10:25. Come back at 10:40. 10:40, and we'll talk business questions and then be done for the day.
All right.
All right. All right. Welcome back, everybody. Welcome, Cameron.
Hey, what's going on?
Hey, good morning. Hey, why don't you introduce yourself to the group?
Cameron Harris, work for People Shores. I don't really know what to say. Nice to meet you all.
Cool. What has People Shores got you working on?
I'm basically a data analyst for Simmons Bank. So just
For-
doing reports for them, stuff like that.
Okay.
Monitoring their jobs.
Okay. Well, we'll all get to know each other, Cameron. We're going to be together for twice a week for 4 months, unless you guys get put on shift. I know Dexter and Cameron. Has there been any talk of putting you on night shift?
Say again, sir.
Has there been any discussion of putting you on night shift?
We already on night shift. Well, working 1 to 9, 1 a.m. to 1 to 10, actually.
1 till
Yep.
10. Okay.
Yep.
Okay. So you're basically off duty right now.
Yep.
Okay. Well, I record the sessions, and I have discussed this with Joey, and I think he passed this on to Tammy. That if you guys are off the clock, we need to be doing this asynchronously, where you watch the videos and we do this via email. You know what I mean? If you've already worked a full 9-10 hour shift, I'm not expecting you to be in attendance at the course, but you know, you were supposed to be given. Joey told me you'd have a couple days during the week when you aren't specifically doing Simmons Bank work that you'd be able to catch up on the videos and assignments.
Oh yeah, see, that'll be tomorrow for me.
Okay.
So yeah. Okay.
So
so just catch up on the videos, or
but well, like I said, if you're off the clock on Tuesdays and Thursday mornings, then I'm not expecting you to be in session, and neither in class in person, and neither is People Shores.
okay.
But you're supposed to watch the videos on your off days and stay caught up. Is that clear?
Yes, sir.
Okay. All right. Well, we'll continue. I wanted to go over one more PowerPoint before I let you go for the day, and that is business problems. Let me go back to that one. And all of this information came from our friends at Google. Google has a career certificate in data analytics. It's like a 6-month program, and I'm about 55-60% of the way through it. It's great on principles and foundational food for thought information. It's a little light on hands-on. We did some querying in BigQuery, is Google Cloud Platform's SQL engine, large big data. It can do millions of rows. Anyway, it was very, and maybe there'll be more. I'm sure there will be more in the future, but anyway, but that course is really good on principles. So if you're, if you like food for thought, or if you're helping put together an analytics effort, it might be good. You can watch the videos at double time speed, and just use the portions of the course that are worthwhile. But we have, through a partnership with a nationwide nonprofit, we have these Google career certificates for free, at no cost to you. And we've got basically an unlimited supply. And it's not just business analysis, but there's project management and a automating IT with Python. There's a more thorough Python crash course available. So if any of that sounds interesting as a supplemental training source to any of you, just shoot me an email so I don't forget, and I'll hook you up with a license. They use the Coursera platform, but you don't have to pay money for them. Okay, so a business problem, and in some of these PowerPoints, I include a link or two in the speaker notes down below. So a business question, it's narrowly defined issue that you can actually start to think about, what data do we have that would solve that, or what data do we need that would answer that question quantitatively, where you can actually say, well, the data says, example, yeah, average revenue generated in the first year from a new email lead. That one I got from working with the folks at Waco Media that own the Arkansas Democrat Gazette. So we went through and identified the value of a new email lead based on follow-on behavior, whether they subscribed or not. That was a fun Python project. And then there's always, looking for basic descriptive statistics of, our most or least profitable, highest selling, least, lowest selling, non-selling. There's a story out there in the press about a Walmart store that stuck out because a holiday item, like I think it was Halloween cookies, in one store out of their 10,000 stores, was not selling at all. And they've got a data cafe up in Bentonville that was looking for outliers like that, and they saw that these cookies were not selling at all in this one store. Come to find out, they didn't take them out of the stock room. Whoops, we forgot to put them on the shelf. So they, the little cardboard display, they blew it. So data in real time can answer those questions. And what customer attributes relate to the highest sales to that customer. That starts to get into perhaps machine learning and cluster analysis and certainly correlation. So but these questions can be super broad. How do we increase sales? Well, let's peel that onion. You got to get more detailed. So I'm hoping when you turn in this Word document, the business questions that you are writing down will kind of map to what we're talking about here. I don't think I put in the instructions to define the type of problem, but you might want to think about that. And this is not exclusive. Again, this comes from a pretty thorough Google course, but making predictions, of course, you look at the trend line, and past data doesn't guarantee it's going to keep going that way, but you can normally predict using historical data and then a little bit of art in there if something happened to I don't know, if an article came out that Turkey caused heart attacks, you might predict that sales would go down even if sales had been increasing every Thanksgiving prior, so yeah, that's why that whole predictive prescriptive analytics gets to be a little bit complicated. You got to work in the data and some scientific wild ass guessing. Of course, categorizing, as typified by the much maligned pie chart, but moving things into categories, spotting something unusual, outliers, and we've got a slide on each one of these. Themes is an extension of number 2. Discovering the way things are connected within the data, and then which is similar to finding patterns within the data. So these are types of problems, very broad, and just food for thought. Just want to make sure that we get that out there. So yeah, predictions. So we can't guarantee that maybe a helpful advertising campaign worked in the past, but often with enough data and enough cycles to analyze, you can start to say that every time we put $12,000 into an advertising campaign, we see a rise in sales or a rise in customers or visits to the website or whatever the case may be. And then you might peel that onion and look at more things that predict other things, or a leading indicator of something else. Okay, categorizing things. You might want to know, like customer demographics, put them in groups, categorizing potential customers by their likelihood to buy. A lot of your companies pay for customer lists. I know, like in the sales world, a sales lead will normally be categorized by its value, and kind of shuffled towards the highest performing salespeople. So yeah, and very often we can categorize, draw things in and aggregate data using a pivot chart. Helps you count or summarize what's associated with a given category of something, like how many widgets did we sell, and if you've got detailed information, you gotta pull that in and pivot it. So we'll do pivot charts in Excel and Python. Spotting something unusual. This is where you might find something that's unusually bad, like the cookies that weren't selling at the one Walmart in wherever, Poughkeepsie. But you can also spot something unusual. Might be an outlier that's good. This could be anything, test scores, scores on it could be survey results. Something that's abnormally good might lead to, there's a few surveys that they're associated with maybe like one salesman or something that, oh, wow, this guy's really good. So he got, all 9s where everybody else was mixed in 5 and 6. And you can use these, it'll stick out in a visualization, like a scatter diagram or a histogram, visually. And then you can look for values that are outside of a certain number of standard deviations, especially 3. If something is outside of 3 standard deviations from the mean of a data set, then it's an outlier, bad or good. Could be good. Could be somebody that's just phenomenal at whatever they're doing, and you need to figure out how they're doing what they're doing. So it's not necessarily bad just because it happens to be an anomaly or an outlier or just or something unusual. Themes could be similar to categories, but it might be like groups of categories that are similar. So you want to categorize, no kidding, because that's what the data says. But then you might further group categories into something similar. I don't know, like kind of like subgrouping. Like you categorize the fruit, but then they would all be in the same theme as fruit, but bananas and apples and oranges might be categorized separately. So yeah, and in my dissertation, I did what's called qualitative analysis, where you basically read what someone told you in an interview and you assign a theme to a similar word. Somebody might have said, in referring to what you need in order to implement a new information system, you might need management support. They might have used the word leadership. They might have used the word higher ups. They might have said C-suite or executives, but it's those words are all associated with the same theme. So even though they're the different word, you go ahead and lump them together as a common theme. So, and you do similar stuff in natural language processing and sentiment analysis. So there you go. And then connections within the data. So you might notice a connection between a certain, like this one says, a shipping company and delayed time. You might notice, and there's mathematical measures. You might notice a connection between, the number of men that smoke versus women, say, and that if you're doing health analytics, that could play in. But yeah, connections within the data, and those can be as simple or as complex as you can think. Like in Python, we'll do for continuous data, for numeric data that is continuous. We'll look at a scatter diagram which shows you the connection between two variables, and if the dots are all over the place, there's no real connection. But if you chart something like age against age in years against height in centimeters, you'll see a direct correlation, and then it tapers off, because you quit growing when you're 18, so you get diminishing returns. But those are the kind of things where you can discover connections between the data. And on a big data set, you can run them all individually, but there's, like in Python, you'll see there's one line of code will give you a matrix of scatter plots for every continuous variable in your data set. Or if you can specify, column 1, 3, 7, 8, 9, and see if there are real quickly any obvious connections between continuous variables. So, it might, your connection might be, your question, your business, might want to know the connection between, I don't know, website traffic and conversion rate, people that convert. Maybe a connection between the demographics of the people that that convert and don't. Could be any number of things. Connection between parts being available and the person deciding to back order it or not. If we have it in stock, they're 15 times more likely to order it versus if we have to back order it or whatever. Could be any number of things. I don't want to put any undue ideas in your head, because you all have practical examples of these. And then, yeah, like I said, patterns within the data. This can be something where you look at maybe multiple variables on a timeline, and you go, oh, look at that. Right before happened, this happened. And look at that, it happened again. So there may be patterns within the data that allow you to answer a question as to what is the leading indicator of something else, what predicts something else, and the trending data might help you do that. So these are types of questions. They're not sufficiently, these examples are not sufficiently fleshed out to actually do anything with them, but it's just a way to think about business problems when you're working with your users, or and if those are executives, or and yeah, you always, with anything, practice makes perfect. Thinking through the problems so that you gather enough information during that conversation, because it could be hard to go back. You want to make sure you're gathering enough information that when you get back to your data, you can make a good start without having to go back. But often you will, and sometimes that's fine, and other times you get one shot at asking people what they need, and you wind up wasting your time if you didn't get what you needed in the problem definition objective stage of our data analysis. So yeah, next one is types of business, or that's an acronym, a mnemonic for how to tell if you've got a good business question. And yeah, there are no dumb questions, but this is, I don't know, a decent mnemonic. So if you'd refer back to this when you're doing your assignment, is the question specific, and does it address the problem? So the problem might be, we're losing money on X. Well, now you got to start asking questions. So the problem is a statement of an issue. The questions are how you start to shed light on that problem. However, the leader or the executive, whoever it is, might want to start tackling that problem. So you're shedding light for them in a problem solving environment. So specific, and of course measurable, because it can't be just something that and Skynet would know. You have to be able to put data to it. And is it action oriented? And this is, as this mnemonic, this SMART, to me is something that your customers need to know. So this might be something that you kind of guide to make sure that they are addressing these things. Is it action oriented? Are they going to act on what they've asked for? Is it actionable? And if you kind of sense that what they're asking isn't quite going to deliver what you might think they need, then you can kind of drive the conversation in that direction. And the next one, are relevant? Is it similar? And then time bound, that can be important. You may not have as much data as they want. Going back into history, there may be a point in time when the data is irrelevant because there was maybe like a reorganization or a product line changed or whatever the case may be. So if there's a time constraint where they want to know after, since this fiscal year, or a lot of times the questions are involved in a fiscal quarter, just make sure you know what the relevant time window is for any business questions that you're analyzing. Okay. So Anybody got a clarification questions before we look at the assignment?
No, sir.
Okay. When you get to the classroom, I put this in student view. When you get to the classroom, you'll see business analytics problems that, and this putting pencil to paper. So that's an assignment. You click on that, and there's the instructions right there. And then after you start the assignment, you'll be able to upload. So if you just like check these instructions, cut and paste them into a Word document. And then, like I said, I gave you an hour on Tuesday, give you another hour today. More is better, so what are the business questions and metrics you'll be addressing? Dexter, you had mentioned, the amount of downtime or the severity of an issue. I mean, you're kind of like a fireman when it comes to a data process breaking, right?
Yes, sir. Basically, we monitor the jobs within the cloud. And within a certain amount of time, it's supposed to run and complete. I mean, it's supposed to queue, complete. No, it's supposed to queue, process, and complete. Sometimes it times out and we have to restart a job, or sometimes the network might flake out and we have to restart a job. And sometimes we just might fail and we have to call a supervisor and get an understanding on why their job failed. So,
Okay.
a lot of different stuff.
So
A lot
that
of
sounds like categorizing. Why did it fail? It failed because bad data, it failed because of a bad process, failed because somebody forgot to start the job, or so
it could be that. Yes, sir.
yeah, it's a little hard to hear you. But anyway, so yeah, use that SMART acronym to kind of, address that first question. And then the data landscape, if you could give me an idea, and like I said, too much information, there's no such thing as too much information. Where it resides, if it's in like, Kevin was working with an environmental monitoring software as a service called Intellex. And for me, all the data I work with is in our HubSpot customer relationship management software, or it's in Greenhouse when you guys were applying to be apprentices and you were working with like Ashley or Nicole or Kristen or one of the recruiter gals. They're all gals. They had your information in Greenhouse. So if we want to do any sort of analysis, we have to pull that data out of Greenhouse and then do with it whatever we will. I use some Excel. I wrote a Python program to look for unpaid invoices, like I said. So as much information as you can give me about the data landscape, to include the people that you work with, and how you get that data. It doesn't have to be, I don't need to know their name, but you work with a data engineer or a DBA or a senior analyst that is asking questions, whatever. If it's the client, just give me as much information as you can. And then from the tool standpoint, I'd also like to know what you're working with and how you're currently answering those questions. And then I'd love to know how these other tools might be able to help you. In particular, and you might learn that as we go through the course, what can be done in Python versus what you would normally, maybe you might be doing manually in Excel. Once you know the business rules, it can be easy to automate something and might make you more productive. So any questions on what I'm looking for?
Yes, sir.
All right. More information, the better. If you post these all by tomorrow night, I'll probably read them like over the weekend and give you some feedback sometime Monday. If something happens and you can't get to this by the end of shift or end of work or whatever on Friday, shoot me an email, because what I've, having done this 4 times now, folks will not turn something in. And here I sit wondering what is happening, what is going on. So if you have questions, or if for some reason you need a little bit of an extension, just shoot me an email, okay? Please don't leave me hanging, wondering what I could have done better to explain things.
Okay.
All righty. And you guys you have my cell, especially on the weekend. If you're by chance running into something, you're welcome to text me. This data analysis course isn't in my ACDS duties. It's above and beyond those duties. So I work on it off hours. I work on it at night and on the weekend. So if something strikes your mind, you got my cell. You're welcome to text me. Okay, guys, I will see everybody.
Hey, what's your cell number? Sorry.
Sister, it's in my email, in my signature block in my email. It's 812.
Okay.
You got my email, right?
Yes, sir.
Okay.
All right.
All right, guys. I will see everybody Tuesday morning at 8:30.
All right.
All right. See you
Good
next
one.
week.